Welcome. In this video I'm going to show you how you can obtain different measures of quantitative variation or measures of dispersion using R. I'm using Jupyter Lab, but the R code should also work in, for example, RStudio. I'm having here R version 4.3 at the moment, and the only packages that are installed at the moment are the ones that simply come with R. In this video I will not talk too much about how to interpret these measures and which one you should be using. I'm just going to show you how you can actually obtain them. The most popular ones are probably the variance and the standard deviation, but there are also others. To show you how this can be done, I need some example data, so I'll load in a data set from the General Social Survey from 2012, adjusted for these example purposes. I need some numeric data, so I'm going to be using the age field. And unfortunately, there are some missing values, so I'm going to be using NA omit to get rid of those. And there's actually an 89 or older category, and I'm just going to replace those ages with 89. It's just an example. Then make everything numeric, so I really have a numeric field. Now, my own library actually has a function that can calculate all these different measures for you, but in this video I'll show you how you can do it without using my library. There are a few libraries. R's own stats library can actually calculate a few. DeskTools can do 2 of them, and then there are a few odds and ends for the coefficient of variation. So the standard deviation itself is available in the stats library, so just call SD and then scale field, and you get the standard deviation. It's also a function for the sample variance, and that's this one. You can also get the median absolute deviation from the median by using the MAD function, and that's in this case 14. All right. If you want the population versions of these, as you might notice, the SD, it actually doesn't have a function for this. So for the population version, you're out of luck, but I'll show you how you can still obtain it later on. The mean absolute deviation, so that's different, that's also abbreviated sometimes to MAD, is available in this package, and its function is called matstat, and apparently that's 14.859. The DeskTools has a function for the average absolute deviation from a specific center, so you can actually use that to also calculate it, and as you might notice, that gives the exact same result. You can also get the mean absolute deviation from the median by setting the center to median, and then you get 14.83798. Note that that's different from this one. So one is the median absolute deviation from the median, and this is the average absolute deviation from the median. So it's very tricky, but these are different. There's a library for the coefficient of variation, which is actually simply the standard deviation divided by the average. So there are a few packages that actually made a function for this. I'm getting each time some warnings, but they still seem to work, all of them. And they all give the same result. So that's one way of getting these. For the ones that are not using the stats, let's go over the formulas then. Let's first get the average, which is done by using the mean function, and then the sample size by using the length. Now, square deviations can be simply calculated by taking each value, subtract the mean, square the result, and then sum all of those and store that result. The sample variance is then simply dividing by the sample size minus 1, and the population version is then just dividing by n. That's the only difference between these two. For large data sets, this usually doesn't have much of an impact. The sample standard deviation is the square root out of the variance, and similarly for the population, but then of course the square root out of the population version. The mean absolute deviation takes the absolute differences and divides that by the sample size, so we can use the absolute function from R to get that. We can also have use of the median. So instead of subtracting the average, we subtract the median. So we use that as our center. So we determine the median using the median function and then simply do the same as earlier, but now subtract the median. We can also take the median of the absolute deviations from the median, and then we get the 14 that we saw earlier. The coefficient of variation, as mentioned earlier, is the standard deviation divided by the average. The last two, they are actually using the deciles, and deciles are a specific version of quantiles. I have a whole separate video on how you can actually calculate quantiles. There are different methods to do this, but for this video I just used the quantile function from R's stats library, and I feed it the 9 different deciles that I want. Then I take the average of all of those to get the so-called decile mean. Now the decile standard deviation is similar again as we did earlier by subtracting the mean. We now subtract the decile mean. Square the results, sum everything, divided by the sample size minus 1, and take the square root. So that's exactly here. Subtract the decile mean, square the results, sum all of those, divide by the sample size minus 1, and take the square root, which is the same as raising something to the power of a half. Last but not least, we can then also divide this by the decile mean itself to get what is called the coefficient of deviation. These coefficients of deviation and coefficient of variation are sometimes useful to compare two different standard deviations with each other. Alright, I hope this video was helpful and thank you for watching.